what? What are we given? A table of
X's and Y's.
X's and Y's and
The
Y primes. Okay? This is one of the AP guys' favorite ways to give you information and ask you what you know about it. And your answer, like in your head, should be, I don't know much. Why? Do you know what's in between those points? No. Could there randomly be a spike in between here and here where it goes up to 13 and back down to -5? Sure. I don't know. Okay? I don't know what's going on in between, but there are some things I can know for sure. And the things I can know for sure, well, guys, have we had enough experience with AP questions in order to say when they say must, is it just what could be true or what has to be true? Which one's more limiting, what could or what must?
Must.
Does that make sense? So, whenever I say must exist, must there be, there must be a theorem I need to use. There must exist a value C. Well, there must be a theorem that applies. Question, hold on. What are they saying must happen? What is R? Are they asking me to find R?
Yes.
Question. I'm given F and F prime, and they're asking must there F double prime. What are some different theorems that say must? Or there is some. MVT, roles, there's another one from a while ago. Extreme value, yeah, says there must be an absolute max, absolute minimum. IVT, there must be a Y in between other Y's. Question. Do we know F double prime so that we could say, hey, where is he at 0? Where is he at 0.5? Is R in between? No. It's not IVT. If it's not IVT, EVT is there's a highest, lowest. Do they care?
No.
It's MVT or roles. MVT or roles. What do both MVT and roles guarantee the existence of?
C.
A C such that, wait a minute, but what kind of C? A C such that F prime of C equals fill in the blank depending on the theorem. F prime of C, they both guarantee the existence of a first derivative. What are they asking here?
Second.
Who is the second derivative, the first derivative of? I'm not even going to look here for this question. For this question, there were like 3 different parts of this question. You know how to do this one. I'm going to look here. Why? MVT and rules say there must be where the first derivative is. Now guys, hold on. Is this MVT or rules? What do we have to assume? What's the difference in the conclusion? Rolls says the derivative has to equal 0. Do I know if R is 0?
No.
So I must assume that it's MVT. How do I make a conclusion about MVT? Well, first of all, I have to ask myself a couple questions, like if, hold on, what's the second derivative the derivative of? So in this entire thing, I'm looking at, wait a minute, if, not if F, but if F prime. So what's my first condition? If F prime is continuous. Hold on, I shouldn't be saying if, should I? I'm giving an answer. I should say since. Can I say that? Why? Differentiable, what's that mean? The derivative is continuous. The derivative exists. So I can say since, I don't have to tell them why on this part. Since, focus. Since F prime is continuous, what else has to be true? And differentiable. Hopefully we had that in that question on the quiz. We have it continuous, we have it differentiable. Why? Aren't they saying F double prime matches with a positive number for all these x's? F double prime is good. So F prime is continuous, F prime prime, F double prime, that exists too. Since F prime is continuous and differentiable, there must exist, can I just use their wording? Totally, and I'll sound smart. There must exist a value C. This is like the bad English where you just restate the question, but we're doing it for our purposes and we're in math, so it's okay. And we're showing we know what they're saying and what it is used in, aka MVT. There must exist a value x equals C such for C within 0.5 to 0 such that, you can write it out. Wait a minute, if they give me in between 0 and 0.5, such that, what conclusion can I make? What conclusion can I make from MBT?
F of B.
Such that this prime, what's that prime? F double prime of C equals, I know they're looking for R, but wait, we have a theorem. What does that theorem tell us? Such that the derivative of is equal to, but hold on, F prime of B minus, wait, what's my B? Minus F prime of 0 all over 0.5 minus 0. Technically, it might have been prettier at the beginning, but that's okay. What did we just state? Oh, you know what? Haha. We'll just do this. We can still make it pretty. I just stated MBT, and MBT just told me exactly what I need to do. In order to find R, I must find F prime of 0.5 minus F prime of 0 all over 0.5 minus 0. How do I do that? 3 minus 0 all over 0.5. Cool kids, we're awesome like this. 3 over 1/2 is done. What'd I do? State a forever card and plug in some stuff. Why was it hard? They weren't asking for F prime. They were asking for F double prime, but that's okay. He's the prime of something. They didn't tell me MVT, but I saw must exist a derivative. Ooh, MVT. There are some things, some conclusions, some connections that needed to be drawn, but does it make sense? Diane. Because it says F double prime equals positive numbers for everything here, well, if it's a positive number, it exists. So F prime is continuous. F prime is continuous because F is differentiable. And then F prime is differentiable because F prime's prime exists everywhere there. Benji.
And why would 0.5 be B again?
Ah, think of your theorem on A to B.
Oh,
A, B. Matthew.
On an
My
AP
guys who were like, I got it, I'm good. Go to number 2. Matthew.
On an AP test, could you say MBT or would you have to say mean value?
MVT, they totally know. Yeah, they totally know. Things that I tell you except for pips. Some people use it, some people don't. So pips, we're going to say possible inflection points. Or possible pips. No, we'll just say possible inflection points. For everything else, IVT, NVT, roles, EVT. I've never seen an FRQ need you to use EVT in it because they don't ask you that easy of a question. What? But maybe in a multiple choice. Guys, let's go to number 2. We want to get further than period 1, remember? Here we go.
we're better.
No, I'm just reminding, okay? Here we go. This is a free response. I kind of had to take some stuff out so that, well, long story short, if you had seen what they actually gave you, it wasn't a G prime, but if you saw what they gave you, you wouldn't understand it yet. But you do know how to answer these 2 questions. If I just show you, well, it's basically the derivative. Find all values of x in the open interval. Why did they say -5 to 4? What's the big deal with that? They're telling me just look at the graph. Don't think about anything that might be happening outside of the graph. Find all values of x in the open interval -5 to 4 at which g attains a relative maximum. Hey, that's a forever. Justify your answer. How many forevers tell us how to do relative extrema?
2.
Okay, what's the difference between the two? One of them says,
First derivative.
how? How do I use the first derivative?
Sign change.
Be specific, don't just say sign change. Sign change
Decreasing.
of the, no, that's not what it says.
Of the prime.
Sign change of the first derivative, f prime changes from positive to negative, I have a, and if it changes from, I have a min. Hold on, pause. Could you restate that using the words increasing and decreasing? You can. Some of you started using it, but you couldn't use f prime. What would you have to use? Where f changes from increasing to decreasing, you're like, oh, well, duh, because f prime is positive to negative. Can you say f prime increasing? Where's that sending you? F prime increasing, increasing, decreasing test sends you to the derivative. If I'm at f prime, where am I going? Derivative of f prime, where am I going? F double prime. That's not telling me about f's relative maximum with increasing, decreasing. There's another way though. Second derivative. How does that one work? I have a critical number. Have to have that first. I have a critical number. And then the second derivative, if it's positive at that critical number, and if it's negative at that concave number, and if it's 0, aka there is no concavity. Okay. Which one do you think I'm using here? First derivative sounds a whole lot easier because I have him. Do I have the second derivative? Kind of, because you can see him, because what is he of this graph? The slopes, the derivative of this graph, so the slopes of this graph. Alright, cool kids, we could say, sorry, I made an optical course. Alright, so would you mind popping open again? Penny, here is, pass back, something about, okay. You want to see a trick?
Okay. Magic.
You gotta think about the justification anyway, right? So let's write the justification and see if it leads us to our answer, just in case you were stuck. Okay, relative max. Have a first derivative. Quote me the forever card. There is a relative max where? Or when? Sign changes of what? Positive to negative. You could actually write positive, you could do plus and minus, they'll take it. What do you think I'm trying to save you?
Time.
Time. But I don't want to sacrifice quality for time. And some of these, could you possibly shortcut? Yes. Is there like a magical way of phrasing? No, but there are magical things to include. They're not magical, they're mathematical, but either way. Come back. Why did I leave it blank? You didn't quote me the whole test. F prime does have to change from positive to negative. They could change from positive to negative at all kinds of points that don't really mean much. It has to be, does have to be,
At a critical number.
doesn't actually have to be differentiable because it could be a DNE. Does have to exist at a point. Guys, think about a sign chart. What's in between the pluses and minuses? Critical numbers. I have to say it's a critical number. If it's not a critical number, could I just like magically make up a number and say, yay, he changes? And he's not the critical number that I actually, does that make sense? I could have like, ooh, plug in way, and there is a sign change, but I need to have the critical, I just made up numbers. I need to have the critical number. So hold on. I need to figure out a place where f prime, wait a minute, I'm not dealing with f. What am I dealing with? We did that in period 1, 2, and no one told me. Oh no. Why am I saying 0 or DNE? Critical numbers are zeros or DNEs, right? How am I going to find those here? Stop. Critical numbers, G prime. No one's correcting me, guys. You're just writing your own right answers. I know, then you're just making fun of me. I know that. Okay. Where are his zeros or DNEs? Cool. How do I know which one's good? I need him to go from, how do I see G primes on this graph? Do I look at the,
Slope.
Look at the Y.
Look at the, where it is on the graph.
look at the Y values or the heights, right? Okay, where do the heights go from negative to positive? No, from positive to negative. Oops.
2, 1.
X equals 3.
Got it, done.
The
What?
Y is a first typology.
What exists here? Just
X
test.
equals 3.
Okay,
Negative heights, negative derivatives to positive heights, positive derivatives. I would go from decreasing of f to increasing of f. What's here? Relative min. What's here if I go from positive to positive? Not a min, not a max. Maybe a point of inflection. Hey, B. Find all values of x in the open interval at which the graph of f has a point of inflection. Okay. Well, we kind of did, didn't we? So let's talk through what we just did, because if I just said he might be a point of inflection, well, hold on. There's going to be a point. You don't have to use this technique, and to be honest, I don't usually, except I think it does help you think through what you're looking for using the forevers. I'm going to have a point of inflection at x equals. How do I find actual inflection?
You find
I
the
need to find
critical.
possible inflection points. How do I find possible inflection points?
Finding the critical number.
But we're not going to say that. The second derivative equal to 0 or DNE, because they're pips, because we're thinking about the second derivative of something. So the point of inflection at, we'll come back to it, since, what makes it a possible? Ah, not F. What are we dealing with? Make it particular, my ones who are going to use random letters like me, because we like them more. G double prime is going to equal either 0 or, you can say undefined, you can say DNE. I'm just going to put both so that you can see both. And what else has to be true? It has to be a possible, but it's only an actual when.
Concavity changes.
Concavity changes of F or the sign changes of, good. So I could say, and, in this example, G double prime changes signs at these points. Donde? Negative what? Negative 3? Yes? No. 1? Yes? 2? Yes. Hold on. At negative 3? We're being serenaded. At negative 3? Why? The slopes change. Why is it so important that the slopes change? It is a sharp point, so it's a possible, and the slopes change. What are the slopes of G prime? That's how I see the double prime. Derivative of G prime is G double prime. So where the slopes change signs, that's going to be at negative 3, yes. Where's another undefined point? There. Do the slopes change signs? Goes from negative to negative. That's not changing signs. Good idea, like pointing out the undefined, but that's not going to be one. Where the slopes change signs, negative to positive, 1. That's 1. And then where the slopes change signs, positive to negative, that's 1. How could you have reworded this question or this answer? You could have said, there's going to be a point of inflection at x equals negative 3 because G double prime of negative 3 is undefined and G double prime changes from positive to negative there, or you could say the slopes of G prime change from positive to negative there, or you could say G prime changes from increasing to decreasing there. They all mean the same thing. Then you could have gone to 1 and say because G double prime is 0 there and G double prime changes, or the slopes change of G prime, or G prime changes from decreasing to increasing. There are many different ways, but they all have to have the same meaning involved. We are on number, sorry, I didn't even ask. Questions on that one that you can ask right now. So I know some of you have questions. Some of this takes time to kind of dissolve in, for you to digest, for you to mull over, for you to meditate on. I don't really want to use the word meditate. For you to chew the cud over. Anyway. Sorry, Parsa, go ahead.
Will our quiz tomorrow be on what we're learning right now?
It is going to involve some of these ideas. I'm not telling you which one. This is a very broad category from MVT to relative max and mins from a graph of a derivative, points of inflection from a graph of a derivative. Hey, another graph of a derivative. And then algebraically finding mins and maxes the way we know how, we've done in our homework time and time again. Here we go, number 3. Some of you, this is a lot. It's okay, get it down. Digest it tonight. There's a YouTube video of me explaining it. What I'm talking about right now is we're recording. That's kind of weird. Talk to you in the future.
So how do yourself? How do we get to those?
Okay. Okay, are you reading? Quick, because I'm going to start going real fast. What do I have? The graph of. Guys, real quick, put a little squiggle through B because technically you do not have the skills to fully answer that. You have the skills to set it up. I'm just going to write this quick. You have the skills to set it up before we talk about the first one. You have the skills to find the 2, because they give it to you. The skills to find f prime of 2 because you have a graph you can look at 2. I have a function I can plug in. I do not, you do not, I do. Sorry, you do not yet know how to do that. It requires integration that second semester because you don't know how to go backwards. Okay. Stop, pause, cross out B, A. Use the graph of f prime to determine whether the graph of f is concave up, concave down, or neither. What am I thinking about with concavity? So couldn't I say, do I really want to label? We could. Oh, never mind, we're looking at specific. So we can't really say which one it is yet, right? Hold on, 1.7 to 1.9. Well, guys, it's a bit messy, but where do I know it is for sure in between? It's in between 1 and 2 somewhere, and I could even kind of say halfway. Guys, this is actually a calculator question. So you could have actually plugged this into your y1 equals, and you could look at it yourself, and you could look between 1.7 to 1.9, but just a quick hint, you don't need to get a graph. You can look at this one for this question. What's the sign of the slopes? Sign of the slopes in between 1.7 and 1.9, actually more specifically in between 1 point something to, okay, never mind. What is it? Negative, so I can say concave down. Wait, how? Because the sign of f double prime, yes, go ahead. Since f double prime, there could have been a couple different ways of saying this. I just decided to be super precise. It's going to be concave down on this interval since the slopes of f prime, you could have said that, or you could have said the f double prime values, could have written out a couple different ways. Or the sign of f double prime of x is negative there. Does that make sense? Could have said it a couple different ways. I kind of put in both. You could say f double prime is negative. Just say it, and they'll be like, good job, you saw that the slopes are. You don't have to write it. Just say f double prime is negative, or the slopes of f prime are negative, or f prime is decreasing. All of that means the same thing. Nick, go ahead. Probably, but on those ones, like where we just did shortcuts for ourselves, I don't know. We might want to be more specific, but I bet they would know what CD is. Is the bell wrong or is it just choir being noisy? Just choir being noisy. Okay, so number 4. Now, we're not gonna be able to finish number 4. I'm gonna go ahead and work out number 4 probably during lunch. Probably not taping it. No, I could probably tape it. I can pause it. I can record again. Anyway, because it's a good practice, right? But guys, hold on. What are you given in this one? I'm given an algebraic equation. No graph, but no big deal. I could graph it if I wanted to, if it was calculator. I honestly don't remember. I don't think it is. Can I find horizontal tangents? How?
Set the bottom.
Top equal to 0, right? Determine whether it has local max, local min, or neither. What do I do?
Sign chart.
Sign chart, right? Or find the second derivative and then plug in. Where's it concave up? Find the second derivative, sign chart, figure out pips, second derivative, pitchfork, right? Plus or minus. I'm looking for pluses of the second derivative. Write an equation for the line tangent. Y minus y1 equals, hold on, do you have enough information? You do have enough information because they give you the
M.
of the original. And then the m is what? The slope, aka the h prime. And then, this one's a little tricky. If it's concave down, the tangent line's above. If it's concave up, tangent line's below. All right, bye kids. Let me go pause my recording before
Oh, Miss D.
we hear people opposite.
Oh, Miss D.